Honor your father and your mother so that you may live long. Greetings to you all in the name of the Lord Jesus Christ. I hope you all remember the topics that we have learned in the last class: linear momentum, Newton's first law, force, effects of force, like parallel forces and unlike parallel forces. So today we are going to see the next topics given in your book. Before we get into the lesson, I would like to teach a numerical problem related to the linear momentum. Here's the problem. Calculate the velocity of a moving body of mass 5 kg whose linear momentum is 2.5 kg ms minus 1. So we know the formula P is equal to m into v. So from that we can take out the velocity. Velocity is equal to linear momentum by mass. The formula for velocity is equal to linear momentum by mass. So here they given the value for linear momentum, that is 2.5 kg ms minus 1, and the value for mass is 5 kg. So you have to substitute the values and the answer will be v is equal to, that is velocity is equal to 0.5 meter per second, that is ms minus 1. While doing this numerical problem, you should note that you must write the formula clearly, that is velocity is equal to linear momentum and divided by mass, and also you should write the answer with the unit. Answer without unit will be considered as a wrong answer, so you should be careful while doing the problems. Next is a resultant force. It is otherwise called as net force, and it is a single force. Easily, if you want to define, you can say that when two or more forces act on an object, the resultant force can be found by adding up the individual forces. Here the definition: when several forces, that is two or more than two forces, act simultaneously on the same body, then the combined effect of the multiple forces is termed as resultant forces. When several forces act simultaneously on the same body, then the combined effect of the multiple forces is termed as resultant forces. Yes, when two or more forces act on an object, the resultant force can be found by adding up individual forces. Now let us see how to calculate the resultant force or net force. Imagine two boys are pushing a car. One boy is applying 10 Newton and another boy is applying 15 Newton. Could you guess the total amount of force acting on this body? Yes, the total force will be 25 Newton. That is, you have to add the two forces. Total force is equal, that is resultant force is equal to F1 plus F2, that is 10 plus 15, we get 25 Newton. So this car moves along the right side. In the next case, imagine two boys are pushing the car and one boy is applying 10 Newton and another boy is applying 5 Newton, but one boy is applying force in opposite direction. So to calculate the net force in this case, the formula will be the resultant force is equal to F1 minus F2 is equal to 10 Newton minus 5 Newton. So the resultant force will be 5 Newton. Since the force F1 is greater than F2, since the greater force is acting towards the right side, the car will move towards the right side. In this case, F2 is greater than the F1. So the total force acting on a body will be 5 Newton. The resultant force is equal to F2 minus F1, that is 10 minus 5 is equal to 5 Newton. The only thing is, since F2 is greater, the car will move along the left side. And in the last case, both the forces are equal. F1 is equal to F2. That is, both the boys are applying the force of 10 Newton. So here the net force will be 0. Balanced force. If the resultant force of all the forces acting on a body is equal to 0, then the body will be in equilibrium. It won't move. So such forces are called balanced force. So in this diagram we can see the force applied by both the sides are equal. So here the net force will be 0. Now let us see about the unbalanced force. If the resultant force is not equal to 0, then it causes motion due to unbalanced force. So in this picture, one force is 50 Newton, the other force is acting in opposite direction is 5 Newton. Both the forces are parallel but they are not equal. So here the net force will be 10 Newton, which is not equal to 0. To make this body to be a balanced one, we have to apply another force in the opposite direction so that it will be equal. It will be in the equilibrium state. So you have to apply 10 Newton. So this force which we applied externally extra, that force is said to be equilibrium. Now in this case, the resultant force will be 0. Let us see the next topic, rotating effect of force. For this, let us take the door as an example. In this door, in all the doors, there are two edges and one edge is fixed by a hinge. These are called the hinges. The other end, we have a handle. So, the distance between the handle and the edge is called the perpendicular distance. You have observed that the handle of the door is always placed at the edges of the door. This handle is not placed in the middle or near the fixed edge or near the hinge. The reason is that if it is placed in the middle or at the edges or the fixed edges, it is hard for us to close or open the door. So the door can be easily opened or closed when you apply the force at a point far away from the fixed edges. So in this case, the effect of force you apply is to turn the door about the fixed edges. So when you apply the force, there will be a turning effect about the fixed axis. This is called the axis of rotation. The axis of the fixed edge about which the door is rotated is called the axis of rotation. Now let us see about the point of rotation. Fix one end of the rod in the floor and apply a force to the other end tangentially like this. This rod will be turned about a fixed point and that point is called this point, about a fixed point, and that point is called the point of rotation. The next topic is moment of the force, or it is named as torque, and this torque is represented by the letter tau. The definition for the moment of force is the rotating or turning effect of a force about a fixed point or fixed axis is called the moment of force. And the formula for moment of force is tau is equal to F into D, where F is a force and D is the perpendicular distance between the fixed point and the line of action of force, what have seen in the example of a door. And the SI unit of this moment of force or torque is Newton meter. The next one is couple. Couple means two. So it is similar to the moment of force, but in couple there are two forces are acting. Two equal and unlike parallel forces applied at two different points is called a couple. For example, let us see one example for a couple. To open this bottle, we have to apply two forces. Two equal forces, both are in different direction. One force is acting in upward direction and another force is acting in the downward direction. So two equal and unlike parallel forces. Since both the forces acting in opposite direction, they are called unlike parallel forces. Applied at two different points is called a couple. So this couple makes a cap to rotate. So this rotating effect of a couple is called the moment of couple. The moment of couple is M is equal to F into S, where M is called the moment of a couple and F is a force and S is the distance. The SI unit for moment of couple is Newton meter and CG's unit is dyne centimeter. Now let us see about clockwise moment and anti-clockwise moment. If the body is rotated in the clockwise direction, then the direction of moment of force or couple is taken as negative. For example, you have to write it as minus 5 Newton meter. The same time, if the body is rotated in the anti-clockwise direction, the direction of moment of force or couple is taken as positive. Then you have to write plus 5 Newton meter. Let's see some application of tasks given in your book. The first one is gear. A gear is a circular wheel with teeth around its rim. It helps to change the speed of rotation of a wheel by changing the torque and helps to transmit power. And second one is seesaw. Most of you have played on the seesaw. Since there is a difference in the weight of the person sitting on it, the heavier person lifts the lighter person. When the heavier person comes closer to the pivot point, the distance of the line of action of the force decreases. It causes less amount of torque to act on it. This enables the lighter person to lift the heavier person. The third one is steering wheel. A small steering wheel enables you to maneuver a car easily by transferring a torque to the wheels with less effort. Assignment 3. Define the following: balanced force, unbalanced force, resultant force, equilibrant, axis of rotation, point of rotation, moment of force, couple, moment of couple. Second question, write the convention sign for clockwise and anti-clockwise moment. Thank you.